All right, well, welcome everybody. My name is James Kress from the KAUST Visualization Core Lab, and today I'm going to be presenting our Scientific Visualization 101 series, the first part in this series on VisIt. So this will just be an introductory hands-on course, just to get you introduced to VisIt, see what it is, and see if it'll be actually useful for what you want to do with your research. So to start off with, like everything's running. Welcome to everybody online. Thank you for joining. And for those of you in the room, I will try to repeat your questions so that so people online can hear and that we can hear it in the recording as well later. So while we're going through this, if you have questions, just let me know. We don't have to wait till the end or anything, so we'll answer your questions as we go. So as we get started, a few different resources for you. We have the KVL website. You can find all of our current and past trainings there, as well as a bunch of other information that might be of interest to you. So check that out if you need to have any extra information on the VisLab. And if you have a project or anything you want help with, you can send that to our general email address at help@vis.kaust.edu.sa. Oops. I don't push too many buttons here. And then while I'm going through the introduction here, if you haven't downloaded VisIt and you want to follow along, you can go ahead and do that here in the first 10 minutes while I'm going through some of these introductory slides. That way it's ready to go when we're there. Also go ahead and download the datasets from the website, as well as the slides if you want to have the slides. And so VisIt, there's a link to the VisIt downloads in the slides that you can use, as well as links to the different VisIt resources, the discussion page, the wiki, and their user guide. So we like to start off these workshops with just a general couple-minute overview of who we are on the KVL side, in case you don't know who we are and what we do. So we're a 5-person team right now. We have varied expertise, as you can see. So our lead, he focuses on information visualization. I focus on HPC and SciViz, and as well as in situ, so working with the supercomputing resources here at KAUST mostly. We have an AR/VR specialist who also works in SciViz, so he does stuff like Amira and Aviso as well, so segmentation and that kind of thing. And then we have 2 data scientists. So if you're interested in data science, need help with AI or machine learning, they can help you out with projects as well. So our expertise in the VisLab generally breaks down into 3 categories. So training and workshops, that's the first thing. You're in one of those right now. We hold 3 different workshop series each term. We have the Scientific Visualization Workshop Series, the Data Science Workshop Series, as well as the AI Tools and Techniques Workshop Series. So you can check those out every term. We have different offerings. Our next area of expertise, and the one that we focus on most, is our data visualization and data science workflows. And so these break down broadly into 4 different categories. We work on HPC visualization, image segmentation analysis, AR, VR, and then large-scale AI and data science. And so we work with users all across campus, the kingdom, and the world to do their different workflows and different science projects. So we're constantly working on visualizations, papers, and all that kind of thing. So if you have a project you're working on that needs expertise, we can help you out in those areas. So again, I mentioned the wiki a minute ago. Here's the URL to that. You can go there to the training page, download the resources for today's workshop. It also has a number of other things that might be of interest to you. Like I said, we have the trainings, we have highlights, so you can see what we've been working on recently to see if there's anything that overlaps with what you're doing. And then some different FAQs and user resources for our different software stacks. So our training events, I already went over these mostly, but they're available in person and live, or online, sorry. So if you'd like to check out our past recordings, you can view all those on our YouTube channel. We have a ton of different recordings across all of our different workshop series going back quite a few years. So those are there for your use. Next, I wanted to just briefly show a few of our different recent highlights, just to give you an idea of some of the stuff that we've been working on recently. So if you have an idea for a collaborative project, let us know, and we can see if it's a fit. So most of these are things that are more of interest to me. So these are more of the HPC and AR, VR side of things. But we've been doing a number of things in AR, VR for conferences and such. So they're presenting their results at conferences, presenting these to users all across campus. We've been presenting a number of different workshops, releasing software, doing particle convection performance analysis, and then stuff like cyclone visualization. So lots of different things we've been working on, and there's a bunch of other highlights that are focusing on AI and everything on our wiki if you want to see those. So moving on to what we're going to work on today. So the whole goal of today is hands-on. So it's mostly, hopefully you'll follow along. That's really the best way to get into VisIt and see if it's something that'll be useful to you. So it's an introductory course. If you have used VisIt before, this will probably be too basic for you, but check it out and see if it helps you. So why do we care about VisIt at KAUST? So the main reason is that it's an open source scalable platform with users around the world. So you don't have to pay for it. You can download it, use it, and it's very scalable. And it's available on all of the major computational resources here at KAUST. So if you need to scale up your data onto Ibex or Shaheen, we can do that with VisIt. So now I've got like 10 or so minutes of just introduction to what VisIt is, what it can do, and some of the basic plot types. So while I'm going over this, if you don't have VisIt, go ahead and download it and get it ready, and then we'll move on to some of the hands-on stuff here in about 10 minutes. So what is VisIt? So it's an open source application for visualization and analysis of mesh-based data. And so that's really one of the important things here is mesh-based. So if your data is not mesh-based, VisIt's probably not the tool for you, or we'll have to find a way to turn it into a mesh. VisIt needs a mesh to operate on data. And it has an infrastructure for parallel post-processing that scales from laptops to HPC clusters, as I said. And it has built-in in-situ capabilities. So if you're running a simulation and you want to do visualization while that simulation is running, we can do that as well. So VisIt supports a wide range of use cases, from data analysis to comparative analysis, quantitative analysis, visual debugging, and even presentation graphics. So there's a lot of different things that you can do, and a lot of different plotting types that you can use. So streamlines, pathlines, vectors, pseudocolors, volume rendering, molecular visualization, and parallel coordinates. And those are just to name a few of the most used ones. There's quite a few different representations you can use for data in VisIt. So how do you obtain VisIt? Easiest way, download the binary from their website. They've got binaries for Windows, OS X, and Linux. And we, the KVL team, manage builds on Ibex and Shaheen, so we get that built and ready to go on there. If you need to do some specialized development, you can, of course, build it yourself. But make sure you have to before you do that, because that can turn into a lot of work. So how do you get your data into VisIt? That's another important question. So VisIt supports over 110 different file type formats. Some of the most basic ones, BTK, Silo, XDMF, and PBTK. These are some of your more basic ones. And you can also import plain text to like a CSV file. And so let's say you have a code that's writing out data and you want to create VTK files. VisIt also has an exporter that will write VTK files from your simulation code if you need something like that. And if you have a newer code that is supporting mesh-based data and conduit blueprint, VisIt has a reader for that type of data as well. And of course, you can write custom readers and everything else. It just depends on how complicated it needs to be. So, some visualization techniques for mesh-based simulations. So the most basic plot in VisIt is called a pseudocolor rendering. And so this is just mapping a scalar field to a range of colors. And so here's a couple of different examples. So you have a elevation plot. Oops, that is too sensitive. You have an elevation plot here. So this is just a pseudocolor rendering of elevation. It's just mapping color to an elevation and then overlaying that on your data. So that's what a pseudocolor rendering is going to be. And on the right, similar example. So this is just a curl, and then you're mapping density onto that curl, and you can watch that as your simulation evolves. Next, we have volume rendering. And so this gets to be a lot more advanced and a lot more computationally intensive. So we don't do a lot of volume rendering until we're really sure we need to use it. But so what volume rendering is that's casting rays through your data, and then it's applying a transfer function to determine the opacity. So let's say you have this reactor core up here. That's still too sensitive. I'm not going to touch that anymore. So you've got this reactor core up here. And so what they've done is they've applied a bunch of different slices. So you can see the internal reactor components. And then they've applied a transfer function that only shows you the areas of really intense heat. So everything else is transparent. Everything lower than a really high temperature is transparent. And the high temperatures are opaque. So that's essentially what volume rendering is. It just lets you get rid of the data you're not interested in and just see the more interesting components. Next is isosurfacing. So this, at first glance, may look like a pseudo color rendering because it essentially is. It's just doing one more step. So it's in this case for 2D. So we're now not applying a color map. We're applying the contour lines. And so this is a 2D contour. So this is showing you the elevation as the contour lines. And so that's what an isosurface is in 2D, is lines. In 3D over here, an isosurface is going to be a 3D isosurface. So we're solving the same value across all of your data. So this is just a single value from the supernova, single value of pressure in this instance. So whatever that value of pressure is, you're seeing that all across the data all at once. And so you can have, of course, multiple different contours in your data at the same time. You can apply opacities to them so you can see different values all at once. So you can get very complicated when you're doing isosurfacing. Next, particle advection. And so this is a really cool one if you have data that has flow in it. So it's just basic ordinary differential equation. And this is you don't have to understand the math, of course. And so this is just a foundation of several flow viz techniques. And so those techniques in VisIt are streamlines and pathlines. So streamlines are instantaneous paths, whereas pathlines are time-dependent paths. So looking back at this vector plot, so this is a streamline. Well, it's not a streamline because there's no line, but if there was a line that was following this dot, that would be a streamline. So it's just following the instantaneous vectors until it hits this sink over here. But a pathline is going to follow your data through time. So when you're progressing through time, your vectors are, of course, going to shift as your simulation progresses. And so then every single step, that particle is going to advect one step, check the new value, and then advect in a different direction. So it's just going to give you one line through the entire time of your simulation. And so we'll do some streamlines later. We won't be doing any pathlines today. So another important concept in VisIt is the idea of a domain decomposed mesh. And so if you're working on Ibex or Shaheen, that's where this becomes important, is that you can then distribute this data across all of those different nodes. And so in VisIt, they're calling this blocks or domains. And so each one of these colors in both of these images is a domain. And so those domains are then partitioned across MPI tasks for processing. And so this one, we've just popped them out so you can see the domains more easily. But over here on this one, this is like 1,000 different domains that are distributed across 1,000 different processors in that case. And of course, you don't have to distribute data if it's domain decomposed. So I have one of our example data sets today has 8 blocks. We'll just be running that on our laptop. You can use domain decomposed meshes on a single node as well. But if it's decomposed, then you can also put it onto multiple nodes for faster processing. All right. So then this is the last slide before we take a quick break, make sure VisIt's running for everybody, and then we'll move into the hands-on portion. So just a quick overview of what the VisIt GUI is going to look like when you open up VisIt. So it'll open up in 2 different windows. You'll have your plotting window, and we'll go over a bunch of these buttons as we go through the day. And that's where your plot will show up. And then you have your main window over here where you have where you do all of your work. So you've got your pull-down menus, and then you've got your active window selector. That's this number right here. So you can have multiple plots open at the same time. And you have to select whichever window you're working on when you're working on your pipeline browser down here. Our data sources. So this is where you'll open and close your data and select your data set in this drop-down menu right here. And your time slider. So as we have our time varying data set, you can play the time steps through this time slider. And finally, here's where all the work is. You're adding your plots and operators. So you'll add a plot, and then you can add operators to that plot as you need. The pipeline browser shows you what your plot and your operators are, and you can hide and show those and do all different kinds of things in the pipeline browser. And then right here, these 2 apply to checkboxes are important, and I'll point those out in a minute. When you first download VisIt, they're usually both checked. I usually uncheck those and then save my settings so I never have to worry about it again. Because if you leave them checked, it will start applying things to plots that you maybe didn't intend it to. And I'll show you that as we go. And then there's this notepad area. And so you can pin different things down here. So I usually pin the engine, and the engine is what VisIt does all of its computation in. So it launches a background process that does the work. And so I usually put the engine down there just so I can see if it's doing any work and if it's stuck or if it's actually doing something. And then finally, you have your output indicator at the very bottom. If there's an error or something, you can click on that and see some text output. So that is a quick introduction to what VisIt is and what we can do with it here at KAUST. So we'll take a 10-minute break, grab some coffee, make sure your VisIt's running, and then we'll jump into the hands-on portion. Break. All right, welcome back. So we'll go ahead and move on to the next portion. This will be our first hands-on session. Essentially just a GUI tour, giving you an idea of the interface, playing with the files, and seeing what you can do. So our data set that we're going to work with is going to be this Gray Scott data. That'll be one of the files on our wiki. And so Gray Scott is just a mini app simulation that we use for teaching here in the Viz Lab. So it's a 3D 7-point stencil code that simulates the Gray Scott reaction diffusion model. So there's two different chemicals in there, the activator, and then what's the other one called? I should just read it instead of trying to remember. The activator and the repressor. So we'll have two different variables in our data, and we can visualize those and check them out. And so I've got two sample visualizations here, one doing some slicing and some isosurfacing, and one just showing you the blocks. So this is the one that I mentioned that had 8 different domains in it. So what we'll do, we'll just open up we'll open up the files, we'll look at file info, we'll learn how to navigate views, check out multiple views, look at window tools, add plots, operators, change plots, operators, and attributes, look at selectively applying operators, and linking some views. So those will just be a brief summary of the things we'll look at in the next 15 or 20 minutes. So hopefully you downloaded the data. Did everybody get the data and know where the data is? Okay. So then we'll just jump right into VisIt. So go ahead and open VisIt. Mine is closed. And once you're in VisIt, what we'll do is we'll just go to open. So you can either do that through file open, or you can just click the open on your sources here, and then go down, and you'll see a number of different things here. You have your host as well as your path. And so host is where we'll select things like Ibex or Shaheen, but for today we'll just use localhost since we're working on our laptops. And then we can just go to wherever our data is. So mine's in downloads, and it's going to be in this folder called Gray Scott. And you'll see there's 100 different files in here, as well as 100 different directories. So we'll leave file grouping on, or file grouping as smart. And so what that's going to do, I'll turn it off. And so if you turn it off, you can open individual files. If you leave file grouping on as smart, it will, for certain types of databases, it'll group them and let you view them as a time-varying data set. And so that's what we want in this case. We have 100 different time steps, so we'll open 100 files at once. So then we'll just click OK. And after all that, absolutely nothing happened. It looks like it didn't do anything, but it did. It went through, it looked at the file information, and we now have an active source here under active sources. And so that's a main tenet in VisIt, is that it doesn't do anything until you tell it to, because these operations can end up being very expensive. So sometimes if you apply an operator, if you're working on huge data, you're talking 20 minutes, an hour. It depends on what kind of data you're doing. So you don't want it to actually do something until you're ready. And so that's why it doesn't do anything until you tell it to. So now that we've got our file opened, I'll show you the file information. So for file info, you go to File, File Information. And so here's where you can see just some very basic stuff about what the data is that you just opened, in case you didn't know what you just opened. So in this case, you go in here, you'll see it opened a database called Gray Scott step whatever, PVTI. There's 100 different time states. And these are all the different cycles, and here's all the different files. But the most interesting part is if we scroll down, you'll see what our meshes are and what our variables are. And so those are scalar variables in this case. So we have a single mesh called mesh, very convenient. It has 8 blocks. And then we have 2 variables. As I said, we have our U variable and our V variable from the Gray Scott code. And so, perfect. Now that we know what we have, we can go ahead and start thinking about doing some visualizations. So that's file info. So then we'll figure out how to do a visualization. So now that we have this, we do a visualization just by going to add under plots, and we'll add a plot. And I said earlier, the pseudocolor is the most basic one, and that's the one that I use the most. So we'll just go to pseudocolor, scroll over to the variable we're interested in, say U, and then we're ready to go. It shows up in our pipeline browser. We see that we have the variable U, and we're doing a pseudocolor. Conveniently, nothing happened again, of course, so let's make something happen. Click draw, and that's when it'll actually go and execute something. And so mine is having a wonderful time scaling my text today. I don't know why. I think it's because I connected to this external monitor. So I need to fix this text so that we can actually read it. And the other issue is I don't like the background color. White, too hard to see, not enough contrast. So if you want just a black background, you can do a simple swap up here. There's a background swap in this black-white with the green arrows. That ends up helping. I like that better, but I still don't love that. So what I usually do is when I'm first doing some visualizations, I'll go to Controls and go to Annotation, the annotation window, open that up, and do a little bit of work in here to make the window look nicer. So user information, that's this user down here and the date and time. I never care to see that, so I uncheck that and get rid of that. And then under 3D, I usually, for today, I don't care about the bounding box or the triad. I'll get rid of those. That'll be less lines on the screen. So your bounding box is just what surrounds the outside extents of your data in the view window. So I'll turn that off. I'll leave the axes on so that we can actually see our axes and know what our values are. And then the most important one is color. So I go to color and I usually change the background to a gradient just to make something a little bit nicer looking. The defaults are horrible. You don't want blue and black. That just looks awful. I don't know why those are the defaults. So go in and select colors that are nice, and usually darker is better. I'll do black and like a warm gray-ish color if we can. That might be too dark. And this is all just for aesthetics, but it hurts my eyes less. But blue is still a little bright, but it's fine. And then, like I said, the text is not scaling well for me today, so I will change my font scale to something smaller. And that's under general. That'll bring our font down so it doesn't look so bad. And that'll work. And then another thing that we'll look at later is under objects here, where we can control the legends. So that's very useful. So for this legend, I don't like them usually being vertical. So I usually make my legends under orientation, change to something like horizontal with the text on top. And that looks horrible with the scaling today. So then we'll go change the font scaling again. So for now, I probably won't mess with that too much today because that takes too much time. But you can do a lot of different things to make it look nice when you're creating your images and your videos. So that's how we make it look nice, and we can actually see some contrast now. We have a darker background, make it a little bit wider. I guess the next thing is navigating your views. So what am I doing? So to rotate your data, all I'm doing is left-clicking, if I can get my orientation here, left-clicking on the data and just dragging it around. So VisIt just lets you move it in whatever direction you want, and you pick whatever orientation you like. And then let's say I don't like how it's centered, so to move the data left, right, up, or down, you hold the Shift key or maybe the Command key, and then hold that down, left-click, and then you can move the data wherever you want. You can center it however you like. Next, zoom in and out. Middle mouse wheel. So a mouse is usually the most important thing when using VisIt, because the trackpads get tedious. So middle mouse, if you want to do a smooth zoom, you can hold down the middle mouse and then move your mouse in and out. You can pick a very fine zoom level, depending on what you need. All right, so that's some basic interaction. Now this data looks very boring, so I want to make it more interesting before we move on. So let's add an operator. So to add an operator, we just click on the plot that we want to operate on, and then we go to operators. So in this case, why don't we do a slice? So 3slice is a nice VisIt operator that puts 3 slices, as the name sounds, onto your screen simultaneously. So if we just select 3slice, our data again disappeared, nothing happened. We have to tell it to draw. And we now have 3 slices, and they are at the extents of our data, so we still can't see anything interesting. How do we change that? So to change our operators or our plots, we double click on them. So double click on your 3 slice, that pops up the window that lets you modify it. So right now it's putting in 3 different planes, X, Y, and Z at 0, 0, 0. So let's move it to the center of our data, and our data goes to around 6.5. So 3 is close enough to the center. So I'll just do 3 in all 3 dimensions and then click apply, and that'll move our slice. Now we can see into the center of the data. And real quick, I'm going to change the axes so they're not in our face the whole time. So you can change your axis type to, say, the outside edges, and that'll move the axis away from your view so it's not in your face. All right, so now we can see something more interesting. So perfect. So now let's say we want to do another plot. So let's see, let's make this one smaller. So how do we do that? So you can either click this new window button up here, but that's going to create a new window with none of your changes applied. So your background's not applied, your text scaling is not applied, any of that. So I don't usually like doing that. So I will click this button here that says clone this window, and that'll give you an exact window clone. And as the operator suggests, it'll clone the plots. So you just go in there and delete the plots that you don't want. And then just to switch between your windows, so I've opened 3 of them. You go up here to your active window and select which one you're going to work in. So I'll move over to window 3 in this case, and then add a different plot. You can add multiple plots to the same window if you want, but in this case, I just want to show multiple plots in different windows. So let's say we want to look at the number of domains. So that's the easiest way to do that in VisIt is to do a subset plot, and it has domains conveniently sitting there. So we'll apply that. And now we can see that we have 8 different domains in our data. And then let's say that we want to start viewing this data from the same orientation. So you can see that I can move this data over here, but nothing happens on the right screen. And I can also click the time slider and play through the data. And since I have at window 3 active, you can see the numbers are increasing on window 3, but nothing happened in window 1. So how do we link them? So there's a convenient way to link windows in VisIt. So if you go up to the top of the window, mine are off the edge of the screen. There's this little button right here to see the rest of the operators in the window. And there's 3 of them. You can lock time, you can lock your view, or you can lock the tools. So for right now, let's just lock the view and see what that does. And then we have to lock it as well in the other window that we're interested in. And you saw the domain plot moved when I did that lock. That's because now they're going to be viewing things from the same angle. So I'll move this one to an area that I'm interested in, and now I'm looking at the other data from the exact same direction. Same thing with zooming in, same thing with panning, everything. So that's convenient if you want to see multiple plots, different windows, same orientation, you can link them. The next issue is time. As you saw, we want to link time, so we'll link time. And now whenever we use the time slider, the data in both of the windows will adhere to the time slider. So we'll click play. Of course, nothing's going to happen on the right because domains are boring, but on the left now, even though window 3 is active, window 1 is playing through time, and so we can watch our simulation progress in time. If you have large data, something that often helps with animation is under Controls Animation. There's an animation button here, and you can cache your animations. So this data is very small, but if your data is larger and you want to play through time quickly, caching it's a good idea. So you can come in here, turn on caching. You can also turn on how you want to play back the data. You can say loop the data or swing. So swing's kind of interesting if you want to see your data play back and forth. And you can speed it up or slow it down, whatever you want. So we'll slow it down slightly and then click apply. So caching really won't do anything with this data because it's so small, but for larger data, it's very helpful. But you will notice what swinging does here in a second if this thing decides to go. So it's playing, And it's not animating on the left, but that's fine. So we're playing through time, and when it gets to the end of time, oh, it's not listening. Oh, because I selected that for window 3. All right, let's try that again. There we go. Da-da-da-da. All right, now it's swinging back and forth. So what swing means, it's like a swing. Plays through time forward, plays through time backwards, and just keeps doing that repeatedly. It can be interesting depending on whatever phenomena you're trying to investigate. Or you can just have it loop if swinging is not for you. But that's why being able to slow it down is important. You saw how fast it was playing there because it was cached. So that's probably too fast. We can slow it down, play the animation slower. That's too slow. You get the idea. Let's go turn that back up for later. All right. So that is linking views and linking time, creating multiple views. What else do we need to do? We showed you navigating views, and so now we can look at some of the different window tools. So I showed you how to zoom in, zoom out, pan, rotate, tilt, but you can also use some of the tools up here in the second row on the windows. So there's a magnifying glass. If there's an area that you're very interested in, you don't have to manually zoom into it. You can just click on the screen, drag, select a bounding box, and zoom right into whatever you're interested in with the magnifying glass. And then you can go back to the navigation tool to move around. Let's say you get lost. So I've zoomed out so far, I don't know where my data is anymore, and I don't know how to get back to it. The easiest way, there's a camera reset button here called Reset View, and that'll just bring you back right to your data. So if you get lost or you want to just easily move back to your basic view, just click Reset. Then if you want to make a quick screen recording and you want your data to move, you can also do that. So there's something called toggle spin mode. I don't use this very often, but sometimes it's useful. You can have your data spin endlessly and at whatever speed you want. So if I grab the data and spin it really fast, you'll get dizzy because it'll spin like that forever. If we can figure out where my mouse went and stop this data, then we can spin it slowly. And you could take a screen recording or something of whatever your data is and do that very easily without using the movie tools if you wanted to. But usually don't use spin, but it's up there if that's something that's useful for you. Another thing is you can, where did it go? Dun, dun, dun. Oh, I lost it. It's under here. It disappeared. There's something called choose your center of rotation. So right now, center of rotation is just the very center of your data. But if you have data that you want to spin in a different way, you can select a different center of rotation. So let's say I want it to spin on this point on the far end of my data over there. So I selected change my center of rotation and then click somewhere on the screen. Now the data is going to spin based on that new point. So sometimes that can help you depending on what you're looking at. But it makes it hard to move if it's not usually centered on your data. And so if you want to undo that, you should just be able to say recenter your data, and it'll go back and put you back in your old centering. All right, what other buttons are we missing? So there's some pick buttons and stuff, but we'll use those in one of the other hands-on sessions, and I'll show you those later. So next, change your plot and operator attributes. So we did that earlier, but the way you change all of your plot and operator attributes is double-clicking on them. So we can change how our pseudocolor looks by double-clicking on it, and you're going to open up all of your different options for your pseudocolor. So let's say you hate the default color map, which you can go in here, go down to color table, and select something that you like better. Maybe hot desaturated gives you a more desaturated view, more colors. Maybe that's better for your data. If none of those work, VisIt hides a lot of the color tables sometimes. So under Controls Color Table, you can open up your color table manager, and you can, I only seem to have the default ones activated on this laptop, but you can select them all, and then you'll have a ton more show up over here. Now I've got a huge list of color tables that are available after I've enabled them all. So maybe plasma is interesting for whatever you're working on. Also, you can create your own color tables. So if you have very specific colors that you want, easily you can create your own, or you can export them and use them in other tools. If there's a color table in here you like, you can export that easily. So let's see. So that's color tables. What else can we do? So in pseudocolor, there's a few more things you can do if you don't want to see the legend. Obviously, you can turn your legend off and get rid of it. And then under geometry, this won't be too useful now, but we'll look at geometry a little bit later, where you can change this to, say, a wireframe, just see the mesh instead of viewing the surface, or you can view it as points, or you can view them all at the same time. You can see your mesh overlaid on top of your data in that case. All right, so turn off wireframe. Okay, so that's how you change your basic operators. But let's say now you don't like the 3 slice. How do you get rid of it? Click the giant X, it's gone. You can redraw and get back to your data again. And then you can go back in and add a different operator. So let's say we want to do something else. Maybe we want to do, what do we want to do? Isosurfaces don't look great on this data. So let's say we want to do a selection. So we want to do an iso volume. So an iso volume is going to take the data between 2 different values and give it to you as a volume, as it sounds. So if we do min and max, that's not going to do anything. That'll just give you all of your data. So I'll do min to max. That gives me all of my data. But so we can see here on the color table, this is useful. We have our max and min values for the data. Our min is 0.1449, max is 1. So let's go ahead and change these to something different. And you can get even more complicated. If you want to show one variable but iso surface by another variable, you can do that as well by changing the variable instead of using the default variable here. But let's do just by the default variable. Say I want to look at the value between 5 and, no, let's say not 5, 0.5. Let's do 0.2 and 0.5. Let's see what that looks like in the data. There we go. So now we're seeing some of the internal structure. And so that's giving us all of the data between 0.2 and 0.5. And then if you want, you can add another operator to this. Let's say we want to do a slice now on this iso volume. And so you see now you're building a pipeline. That's why this is called the pipeline browser. So it's going to do these orders, these operations in order. So it'll do an iso volume, then it'll do a slice, and then it'll render it. So that's how the pipeline works over here, is it operates in order. Or you can do something like a slice, and then you can do an operator on that slice if you want. And we'll do that on some other data. But I want to be able to slice the iso volume, and then we'll do around the middle again. 3. Let's see what that looks like. And so now we've got just a slice of the iso volume sitting in the approximate center of our data. And so that's how you can chain together different commands to make an interesting pipeline. All right, what else? So selectively applying operators. Oh yeah, mine are all still checked. And so I'll show you what that means right now. So I'll leave this operator and I'll add another, or this plot, and I'll add another one. So let's say I want to do another pseudocolor plot, this time of V. So if I go in here and click draw, you're going to see it shows up exactly where my other plot is. And why is that? That's because, I'll make this window bigger so we can see it. I left the apply operator to all plots and apply subset selections to all plots checked. And so what that means is when I added this new plot, it added an iso volume and it added a 3 slice automatically to that plot. And usually, I hate it doing that, so I usually always uncheck those. And I will delete this plot. And so how you do that, you go up here to delete and just delete the whole thing. And I'll re-add it. So I'll now add again the pseudocolor of V. And now you'll see with those apply to operators unchecked, no operators were applied to V. So now it's just plain old V, and I can do what I want to it without it doing the other operators that I'd already done on the previous data set. And so something else interesting, let's say I get tired of V, I want to get rid of it for now, but I want to bring it back later. hide and show. I use that all the time. You can just hide the data set and it goes away, or bring it back. So we can hide U for a while as we work on V. Let's say we want to go into V and do a different selection on V. Say we want to do a clip. And so what a clip does is that'll give you all of your data between two different planes. So what we'll do in this case, to choose your normal. So that's going to work on either the X, Y, or the Z plane, or combination thereof, depending on which one of these you set. So we'll just leave it as it is, because that'll work on the X plane, because it's 1. So that's X is 1, Y is 0, Z 0. So it's going to work on the X plane. And our origin in this case might work as 0, 0, 0. I don't remember. Let's see. So we'll just say apply and then draw. No. So if you make a plot and there's no data, VisIt will warn you and say, hey, there's no data here. You did something that produced nothing. So now we need to figure out where we want to do this. So let's change our origin. Let's try this in the center of the data. And we'll see what that looks like. There we go. So now we're approximately in the center, and we've clipped our data. So all of the data that's missing, we've gotten rid of, and all of the data that's showing is what we're keeping. And if you want to do the inverse, there's a nice inverse button, so I can keep the other half if I want and get rid of this half. So click that. Now I've got the other half of the data back. And now if I want, I can show you again. And so this is where you can start doing some nice, interesting visualizations. You can show multiple things at once. Start playing through time, see how things go. Let's see. So that was the apply to. And so that one sometimes trips you up if you're not careful. So just be careful of that. Usually I turn it off, and then I usually save my settings once I do that. There's a save settings up here under options in VisIt. It'll save some of the basic settings, and that'll keep the apply to turned off on each subsequent restart of VisIt, so you don't have to do it every single time. Let's see. All right, finally linking views. So I think we've covered everything in this quick GUI tour. Are there any questions before we take one more 10-minute break and then transition into the second hands-on session? All right, if not, I'll see everybody back here in 10 minutes. All right, welcome back. Let's move on to our hands-on session 2. So we're going to switch to a different data set here, try out something new, and we're going to go through more basic plots, slices, contours, and just check out some of this new data set. So what we're going to be working on is this data set's an Arabian Gulf data set generated from one of our research partners upstairs in the Climate Change Center. And so it's a single file. It's a VTK binary XML format called VTU, called Arabian Gulf. So hopefully you've downloaded that. And of course, we all know where the Arabian Gulf is. Here's a picture of it up here so that you can remember what it looks like and what orientation it should be in when we're viewing it. So let's go ahead and open it. We'll just go ahead and delete everything that we've got. I don't need 2 windows anymore, so I'll get rid of one of the windows. And then just delete everything, and you can also close the data if you want. So we'll go ahead and do open. Go back up to the data, Arabian Gulf BTU. Click OK. It'll take a second as VisIt parses the headers of the data, and then it's done. So now it's ready to go again. So what we're going to do now, let's just take a look at the pseudo color of this data, see what it looks like. And what do we have? So we have 5 different variables. We have potential temperature, salinity, and then we have 3 different vector components. So this is what we'll be doing some of our vector visualizations in. So we'll just look at, say, temperature, see what the temperature looks like in the Arabian Gulf. Click draw, thought for a few seconds, and then it did it. So looking at this data, it doesn't look like it's in the right orientation, right, based on our map. So it's kind of backwards. So we need to do some work to make this actually look like the real Arabian Gulf, because this is the bottom. We can see how how jaggedy it is, and those jaggedy lines are your actual cells of your data. So that's just the resolution that we have of this data. That's why you're seeing those cells. Over here, if I can use my proper buttons, see the data looks very smooth at the inlet to the Arabian Gulf. And that is because this data has been truncated. The Arabian Gulf is far shallower than it is over here at the inlet. We've just gotten rid of those lower levels because they would go down way down here somewhere. There's a huge disparity between the depth inside the Arabian Gulf versus the inlet to the Arabian Gulf. But we don't have that data today. So how do we make this data look correct? So this data is wrong, so we need to apply an operator to it. So if we go to operators, we can then do a transform on this data and actually transform it to look like how it's supposed to look like. So the reason that it looks like this is how the scientists operate on the data in the z direction. They don't have an idea of a negative z axis in this case. So we actually need to do a transform. So go to transforms, transform twice, and then click OK. And then open up your transform. And we want to do a scaling transform today on the z-axis. And so what that's going to do is that's just going to invert the z-axis. And so you just put a negative in front of the 1 on the z-axis, click apply, and then click draw. And so what you'll see now is our data has flipped orientations, and now it matches what we expect it to look like in the Arabian Gulf. So that's good. We can see our data. It looks the way it's supposed to look. Now we can start doing some operations on it. So again, we can just do some basic operations. We can then go ahead and apply. So we want to do a slice. Take a look at what the slice of the data looks like. This appears. So if you're doing a single slice, you can select which direction you want to slice along the x-axis, y, or the z. So if we choose z and percent's easier, we don't have to know a real number. We can say I want to look at the middle of the data, 50th percent of the data along the z-axis. Click apply. And what we'll now have is a 2D slice. So we've got a 2D slice. So I'm going to go back into the 2D slice and click uncheck this box that says project to 2D. So I still want to be able to see this in 3D. And then click apply. And so now we can see what the middle of the data looks like. See, it's right in the middle. But we're kind of lost now. We don't know what our dimensions and orientation of our data really is. So let's go ahead and create an outline around the top of the Red Sea so that we know where we're at. And so what I mean by outline in this case, so if we go back to the slice and instead of going to the 50th, I think it's either the 0 or 100. We get 50-50 shot, so it's not 0. So go to the 100th percent slice, and that'll give us the top of the data. And so I want to outline the very perimeter of the data up here so that we can see where the shoreline is. And we can then, it'll also circle all of our islands and everything else that we have inside the data. And so we can operate directly on this slice now if we want. So we have a slice, and how do we get the external surfaces of a slice? There's a convenient operator called external surfaces, and that's under geometry. So we go back up to operators, scroll down to geometry, go to external surface. And so what this will do now is simply grab the external surfaces of our slice. So that's very convenient. Now we have all of our islands are circled, everything, all of the external surfaces are circled. Coloring is wonky now because we're coloring by potential temperature. So we need to go into the pseudocolor plot, double click on it, and we'll then go to geometry. Stay in geometry. And then I'm going to do this as a wireframe. That'll let us change to a single color. The problem with pseudocolor plots is you can't do single colors unless you have defined a single color table. So the pseudocolor plots only work on color tables. So we could, of course, define our own color table if we wanted. That would be a single color. Let's see. Let's find an easy one. So gray. And so if we go into gray, we can say, let's change this to yellow is a nice bright color. Let's see. And then we click new. So we're just changing the name from yellow to new. And yeah, just get rid of the word connect. So new. So now we have a user-defined yellow. Now let's go into, where did it go? So it's right here. Now we can go ahead and change these colors. All right. So to change the color, you right-click on this little color selection dial, go to yellow. We can go to the other end, select the same color. Now we have a single color map. So you can also do it that way if you want. So we'll click apply. And now I need to turn on user-defined. That disappeared. So then turn on user-defined. Now if we go back, we can go to color table and find yellow somewhere in this list. I should turn it, it's clear at the bottom. Perfect. So that's one way we can make this all yellow. So that was quite easy. Or if you don't want to make your own color table, you can also just go back to geometry, as I said, turn off the surface, turn on a wireframe. That'll just give you the mesh, and the mesh in this case is just a line, so it's the same thing. So we can just do a line, have a single color, and it's just as easy as that. So, pink is hard to see. Go back to yellow. No, yellow is going to be hard to see too. Stay on white. And then generally increase your line width so you can actually see it when you're working with other data. So go to say 5 or 6 or something. And now we have our outline. Oh, one last thing. Turn off the legend, because this doesn't make sense to have a legend anymore, so that's gone. All right, so now we've done a lot of work to get a simple line, but it'll look great when we add another plot. So we'll add another pseudo-color plot of salinity, say. Draw that. We'll have to also do the transform on it, because it's going to be upside down again. So add the transform operator, add the scale and the negative z-axis. Apply. Now you can see what I was talking about. So now our data is perfectly outlined on the surface. So if we go ahead and then apply another slice to this data, we can still see the surface of the ocean and kind of give ourselves a reference point of where we're at in the sea at that point. So another slice on the z-axis just so we know what we're doing. Go back to the 50th percent. Type it in, I can't. All right. Draw that. Up. Oh, and that was a nice warning. I should show you that. So it's saying the plot types do not match the spatial dimensions, 2D versus 3D. And of course they don't, because I didn't uncheck the box that I was supposed to check. And so VisIt will only let you show 2D data if all of your data is 2D. So that's something we'll work on when we get to vectors. We need to actually have all of our data be in the same spatial dimension so that it can be shown at the same time. So the slice had this project 2D option, and I had left that checked, so I'll uncheck that. And now that slice can be shown in 3D. And so now you can see where we are. We're doing a slice 50% of the way down in the Arabian Gulf. So that looks pretty cool. And let's say we want to see a cross section. That's just a z-axis slice. So how do we do that? So the easiest way is, if you want to do another same exact slice, is just to copy your pipeline. So you can right click on the salinity pipeline here and go to clone. And then it'll make another one, and then just go in there and modify your slice on that clone. So just go in there, instead of doing a z-axis slice, let's say we want to slice on the x-axis, which will slice it across, relatively straight across on the x-axis. And let's go, I don't remember which side is the start. We'll see where 20% is. And then click draw. All right, that is where I wanted to be. That's not very interesting up there, so let's move it down a little bit. Let's go to 40%. That's a little more interesting. The data is not changing too drastically there. It's mostly static in those areas. But now you can start seeing what a cross-section of your data looks like on Z and X. So you want to do a Y as well. You can just clone that again and do a Y. Choose a different percent. And we'll just see where we are. Done. Click draw. There, and we can view the data from over here. Yeah, maybe that's not the best place. So let's go a little bit further into the data. 60%. Up too far. And so now you can start to see why visualization takes so long. It's very, very subjective, and there's a lot of finicky twiddling you have to do to get to what you want to see. And so this is cool because we actually intersected with two of our islands here. So that's something cool to see. You see that we have obviously no data because there's no ocean under those islands. So it's empty underneath those slices. All right, so that's a bunch of different slices. What else can we do? So dismiss that. Make those smaller. So let's say I'm going to clone it again so I don't have to redo the transform. And I'll delete the slice. And let's see, we can do something else. We can do some other type of selection. There's a lot of different selection types in VisIt. Box selection, clips, cylinders. You can do isovolumes. We already did that a little bit. Threshold, that's another interesting one. So if I want to do a threshold of salinity, our min value is 24, max value is 69. And so what a threshold is going to do is it's going to give you all of the data between two values. So that's very simple. And then you have the idea of part in range and all in range. And so that gets into the nitty gritty about how cells work. So this data is point centered. And so each of our cells is an average of 4 different points. And so if you're going to do part in range, that'll give you partial cells because your data may be intersecting a cell. All in range, every single value within that cell will have to fall within your min and max values. And we'll see what the differences look like here in a second. Let's say I want to get between, I want to do some of the higher temperature or higher salinities. So we'll do 58 to 69 and see where they're, let's do 58 to max and see where those are. Draw. There we go. That's only in one place. That's cool. You can start to see where the salinity is really high, and it would make sense because now you're on this little tiny bit of the ocean over here where it's going to get extra hot and extra evaporation and extra salinity, and it's extra shallow. So your salinity content's going to go up a lot. And so I don't know if all in range or part in range will do much with this data, but let's take a look. So part in range, it did. So you got a few extra cells when we did part in range. So we'll do that again. All in range. We'll take away some of the data. Part in range will give us probably one more cell in some of these different directions because one of the points of that cell doesn't fall within 58 to max. One of them is lower. But so we'll go back to part in range. There we go. So that's cool. We can see some of the areas of super high salinity. If I don't get lost. Okay. Maybe we want to see some areas of super low salinity. And so you can see how your pipeline browser can start to get cluttered as you start to add all of your different visualizations and all the different things you want to be able to see. So let's do something like min to 30. I don't know what that's going to look like. Min to 30. Part in range. And click draw. I don't know where it is. Must not be very large data. Let's see. I don't know where it is. So if you want to find out where it is, you can turn off all of your other data and see what it looks like. There it is. Not much. It's a couple tiny little points. So I selected values too low. So we'll go to higher. We'll do min to 35. See if that's enough. Nope, not really. Not a lot of low values for salinity. I guess we should change this to temperature. Maybe that would be more interesting. So you can do that. So let's say you're tired of salinity. You don't want to delete this pipeline. You just want to do a different variable. That's easy. So you just highlight it, and there's this variables drop down, and that lets you change the variable that you're operating on. So instead of salinity now, we can go back to temperature, and we can take a look at temperature, and we can do a threshold on temperature. Our values, of course, are different, so it's between 15 and 32. So let's see, min to 20, and see what that looks like. That's cool. So now we're getting some of the cold water at the inlet. And we'll turn on our other plots again so we can see it all together. There we go. Super cold water down there at the bottom. Super high salinity up here behind these islands. All right. Cool. And it's starting to get very cluttered on the screen. And so what I would do in most of these cases, since they're the same thing, and you don't need to have a legend for every single slice. So most of the slices that are the same slice, just go turn those off so that they're not taking up your view. And then dismiss. So now we have salinity and potential temperature as our only two color bars. And cool. All right, what else were we going to do on today? So we had basic plots, slices, and contours. We didn't do contours. So let's see, what does a contour look like? So we'll clone this again. Delete the threshold, go in and add a contour. So contours are going to be under somewhere. Selection, probably. Forgot. Selection. No, I was wrong. Isosurface. So they're called isosurfaces in this case, not contours. So an isosurface. And so VisIt has a number of different options you can do for isosurfaces. You can do, it'll select n number of levels between the minimum and maximum, or you can select exact values if you know the exact value that you're interested in. Let's say we're doing this on temperature, so let's say we're interested in value 58 and value 35 and value 60. Then you can apply those and then click draw. Oh, no. All right. Clearly did something wrong. Let's try that again. Maybe. Is it because I did it in order? No. Okay. Might have typed those in wrong too. Let's see. Let's try 10 different levels and see what it does. Dun, dun, dun. There we go. So that gets really messy. So 10 different levels in this data doesn't look great because you're just seeing the perimeter of all of the, so we're doing temperature. So this is where the temperature is exactly those 10 different values. So yellow, somewhere in the 29 degree range, orange, 30, something like that. So don't know why my value didn't work. Let's see. Dun, dun, dun. I don't think they take commas. Let's try one value. Oh, all right. Maybe they do take commas. Sometimes you use commas in VisIt, sometimes you don't. Nope, doesn't like commas. 29, 50. Well, that one works now, so well. Okay. So contours work really well for some data, not very well for other data. For this kind of data in the Red Sea, doesn't produce anything that's too great to look at, so you're not gonna like it too well. But it's very powerful for other types of data. And of course you can do things like percentages. You just want to select the 50th percentile of your data or something like that. Another thing, if you want to select 10 different levels between a specific value, you can do between a specific value. So say I really care about the data between 40 degrees and 55 degrees. No, that's the wrong thing. We're doing temperature. Between 25 degrees and 32 degrees. 25 degrees and 32 degrees. Now it'll select 10 different levels between those minimum and maximums, instead of going all the way down to 15. So those don't look good, so we'll hide those. But now we have a somewhat interesting plot of the Arabian Gulf of temperature and salinity, 3 different slices, as well as an ISO volume, And we did some external surfaces. So there are any questions? What time is it? 3 o'clock. Is there any questions before we take one more break? And then we'll move into the last, hopefully most interesting part of the day where we're doing screenshots and movies and other things. All right. 10 minutes. We'll be right back. 5. All right. Welcome back. So let's move on now to hands-on session 3. So now we're going to get into screenshots, movies, animations, custom expressions, queries, saving your visit state, and more. So this is more of the interesting stuff, how you'll show your data to your colleagues. So we're going to go back to the Gray-Scott data in this case. So what I'm going to do is I'm going to clear everything, which I guess I was. So then we'll go back to the Gray-Scott data. All right, and so the first up is screenshots or movies. So just go ahead and create a quick plot, whatever you want, of some data. You can keep the Arabian Gulf if you want. But as we do movies, it's better if you have time-varying data. So then I'll add an operator real quick. Say a 3 slice. Apply draw. Oops, I didn't click apply. All right, that's in the wrong spot. 3.5, 3.5, 3.5. Okay, that's closer to the middle. All right, so screenshots, very easy. Get to a view orientation you like, and then you simply go to File and Save Window. But first, do your save options so you can save it into a directory that you're able to find. So we'll go to Downloads, and file name, it'll append names to that. So if you want to change it, you can. I usually just leave it the same. Check whatever file type you want to save out, your file size. You want to do something with a little more resolution, or maybe it won't since I don't have a high-res screen today. And then say apply, and say dismiss, so that we can go to File, Save Window. And it's mad because I already saved some files in here earlier. So what is it saying? Currently, you cannot use non-screen capture mode. So I have animation caching turned on. So that's fine. We can turn on screen capture mode. That'll capture your actual screen. The file, set save options, screen capture. That'll just save at your current screen resolution. And then file, save window. Okay, and then you can see down here it's saved, downloads, and this one's called VisIt 0005. Right there. And it saved at my screen resolution, so if we want to see what that was, in this case, what is it today? 3466 by 2304, so nice high resolution image. So images, super easy. What if we want to save a movie and see what this data looks like over time? That's also very easy. If you want to do a basic movie, you don't have to do anything special. You just go to File, Save Movie, and then you can create your movie from here. You can get complicated if you want, but we'll just do an MPEG movie. We'll use screen capture mode since I have animation caching turned on, and we'll move that over to the output, and so that'll output one movie. You can output other movies too if you have different windows or something. You can select different sizes and do multiple movies at the same time. But today we'll just do one, so then we'll move on to the next one, and then here's where we can say how fast we want the movie to play, 10 frames per second, what frame we want to start on, so that's the time step, so time step 0 to time step 99, and we're going to go and render every single frame, and we're going to start at the initial frame of 0. So that's good. And where do we want to save it? Save it back to downloads. It'll be called movie. And it's fast, so we don't need to get an email about this. And now we can use our currently allocated processors. That's easiest. Just click OK. It'll open up its command line interface and launch off a script to render the movie. And you can see it says generating movie. And down here at the bottom, you can see it saving all of the different individual time steps. We're already on time step 40, so 60 more to go. And then our movie will composite and be done. Time step 90, so it'll composite the movie here in a second. And you can watch that in the terminal window, if I can get that to show. There it is. Terminal window, it's done, it's composited, everything's done. Oops. We can click OK and go take a look at it. All right, movie. Should be that one. Maybe, yeah. So, and we've got our movie, and you have your movie over time. But what if you want to have a nicer movie and where things change? It's not just static. So that's also quite easy to do. So instead of having everything be static, we can create move to the next slide, we can create an animation. And so that's done through keyframing. So if we go to controls, scroll down to keyframing, it'll open up the keyframe editor. And you can have more keyframes than you have time steps, but it's just easier to have them be the same for today. So I'm going to type in 100, click enter, and that will give me 100 keyframes, which will directly correspond to 100 time steps that we have. And so as we go over time, we can animate this data. So right now, you can see we have one plot. We have all of our different attributes and our slices and everything in there. And all of these things are keyframed. Oh, that's what these little markers mean. So if we want to enable this, we need to enable it. So click the enable and then click apply. Now we have a time slider and we can slide this over. So let's go over that many time steps. And we want something to change between the first time step and this time step. How do we do that? Let's say we want to change two things. We want to change the view. So I'll go in here and I'll just move. Say I want to look at the data from this direction now and zoom in one level. So I will just go back here now and I will say add a view keyframe and click add view keyframe. And you can see that showed up as the view. I messed up and didn't do my first view. So my views aren't going to change. So I'll go back to where I was and add the first view. Add view. Now we have two views. Now if I scroll between the start and that other view, the data will rotate. So it'll show up over there. It's not doing it smoothly right now for some reason, but it'll do it smoothly in the video. But let's say we also want to animate this 3 slice. It's cool if it stays in the middle, but it's also more interesting if it does something. So let's say I want to go to the value of 2 in every dimension between these first 2 keyframes. Oh, that's not a good one. I want to go the other direction. That way we can see something. Let's go to the value of 5. That's also bad. What direction is that? That's the z-axis. So z, I'm going to move that to 2. Now we can kind of see something. Okay. So then we'll go in here, and you can see automatically already it added the keyframe for my 3 slice. Because I went in there and I changed the attributes. It keeps track of those automatically. So now let's go a little bit further. We'll go way down here. And let's say I want to go to z of 0. Go to 6 on each of these. Click apply. That'll show up. And then we'll go all the way to the end and do a different view and zoom in over there. It's not going to be a pretty movie, but it'll be a movie. So we'll click add view keyframe. Now we do the same exact thing, just render the movie again, and we'll see what our keyframe, but we can actually watch it as well. We don't have to render it if we don't want to. So you can watch it by choosing your active time slider. So the keyframe time slider is active. If we step back to the start. Now we can click play. Spun too fast, but you can kind of get the idea of what it's doing now. So it's zooming in, and our slices are moved too far, so it wasn't as interesting. We should go back and edit those. But you get the idea of what a keyframe is. We'll stop that and go back to this. I will leave these keyframes something different. 5.5, so it doesn't go away. 5.5. That's a little better. Okay. So yeah, so now like I said, if you want to save the movie, it's the same thing. Just save the movie again. Dun, 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 dun. Movie dash keyframes. Okay. And you can also use a new instance of VisIt if you want. Then it'll just do it in the background, hopefully. There we go. It's running. That way you can still keep working in your current instance of VisIt if you want while the movie is generated. But we don't get to see how what the progress is when we do that. So let's see if it's done. It's generating our keyframe, so it is working at least. See, it's on time step 47. $60. And so that just gives you an idea of what you can do with the keyframing. You can animate everything, your view, your orientation, all of the different operators inside of your plots. You can change color palettes between different keyframes. A lot of different options on making very complicated movies. This one's just basic. So now it's compositing in the movie. Movie keyframe, it's compositing, should be done in a second. How big is this movie? 18 meg, so yeah, it's not quite done. 8 megs, still not done. 10 megs, almost done. 11, all right. 14, all right, it'll be done in just a second. In 16, all right, should be done. No, not quite. Still not done. 17, yeah, it's still going. See if it plays. It might play. There we go. So you have to be careful on how quickly you animate things, because we spun really fast there. But it gives you the idea of what you can do with the keyframe animator. So that's keyframing in VisIt. What's next? So next thing, queries and picks. So these are interesting if you want to learn about your data, you're doing debugging, you're trying to do some analysis and figure things out. You can start doing some picks. So how we do that, we can do that on this data. We just go to controls, go down to picks. We'll start with picks and then we'll move on to, we'll go back to queries. So pick, what this will let you do, let's move it over here, make this window smaller, is this will let you select your data directly on the screen and show you the values and cell numbers and everything of that data in your, over here in the pick window. So to do the picks, there's different ways. You can select them right here in the toolbar. There's this one. It'll show us our tooltip, our zone pick, our node pick, and our spreadsheet pick. So today we'll just use zones. So click zone, find something interesting in your data that you want to learn about, click on it. You can see it put the letter A there, so that's our A variable, B, C, D. So now we have all of these different picks that are available for us to learn about. And so if we go back to A, it shows us what mesh domain we were in. So that was the 5th mesh domain that we picked in. This is the exact point that we selected, the exact zone, all of the different nodes, all of the different cells and points that are around our data, as well as the actual values of that data. So if you see something in your data that you think is wrong, you can come in here and see exactly what the value VisIt is seeing in your data by doing a pick on it. Oops. And if you don't go back to navigate and you keep clicking your data, you're going to keep getting picks. So go back to navigate, and then you can move around again. And once you're done, if you want to get rid of these letters, all you have to do is click clear picks and they'll go away. So that's a quick, simple way to take a look at what your data values are. And then next, queries. So these are very powerful. So you can do a lot of data analysis with queries, and you can script queries, you can combine them, chain them, make them very complicated, or you can just use the nice built-in ones. So for instance, if I want to know what the minimum value of my data is, I'll go to minimum, and there's 2 different options here. There's original data and actual data, and so that's important to know what we're talking about there. So right now, if I did the minimum value of actual data, it's going to give me the minimum of the data that I'm showing on the screen. So that's what it means by actual data, the actual data that you're showing. That's after you've applied any operators and gotten rid of some of your data. So if I do the minimum now, you'll see the minimum is in this exact node in domain 5, and its value is 0.7. If I go back to original data, this will just do the minimum of my entire data set with no operators applied to it. So it should be a vastly different number. See, so now we're down to 0.17. And so this is a cool way that you can actually query your actual data that you're currently looking at if you want. Also, you can do this query over time. So as the time steps change between 0 and 99, we can see what our minimum value is, and it'll give you a nice graph to show you how your value changes over time. Maybe nice is the wrong word, but it'll give you a graph. So you have the value starting at 1.0, and as we go over time, I don't like how it does points and 10 to the third, but anyway, as we get to time step 100, it drops off very quickly from 1 all the way down to point something, and then it goes back up slightly. So you can see how your data changes over time by doing queries. Let's see, so let's say we want to see what the max looks like on the same thing. So we'll do another query of max. Oh, max stays the same, which I guess makes sense. So we've got max over time. And then there's other basic things you can do if you want to know what your current memory usage is. You can query that using 50 megs. Do min-max. That one doesn't let you do over time, but you can do the min-max at the same time, get your minimum maximum values. All different kinds of things. If you want to go to something that's only mesh related, you can select your actual, change your display up here to only show you ones that are related to the mesh. So you can start talking about 3D surface area, all of these different types of things. Lots of different built-in queries. And if you want to get serious, you can go into your Python editor, create your own queries and do more advanced queries that way. Something I usually always do, like check, we want to know what the viewer requires a volume. Well, of course. All right. Where did it go? So normally, I'll check things like the grid information, the min-max values, spatial extents. All of these things are useful when you're trying to figure out slices and everything. So you can come in here, query, see what your min-maxes are in every dimension, get the proper way to do slicing, all through queries. So that's queries and picks. We're almost out of time. So what else can we do? So this one's super important. So if you want to quit for the day, you're tired of working in VisIt, but you want to come back later and not have to redo everything, well, you should save a state. So to do that, you go to File. We can go up here and save our session. So that'll let us save a session file, and you can then just reload this later, get back to where you left off without having to leave VisIt open over the weekend. So we'll just go save this in, I should have stayed where I was, save this in downloads. We'll just call this, here it is, workshop session. So now I can come back tomorrow, load up this session, and it has the same exact background and everything, which is nice. So we'll close that. Hopefully it'll work. VisIt. Oops, not Visual Studio. VisIt. There we go. So then to restore our session, we'll go back to File. We'll go back to Restore Session. And another important one is Restore Session with Sources. So let's say you want to give this session file to one of your friends, and they don't have the same file paths on their computer because it's a different computer. So you can restore session with sources. So I will navigate to my session in Downloads, Workshop Session, select OK. And here's where your friends can then give it the proper paths to their data. So they can come in here and tell it where their data is on their computer. So that's Restore Session with Sources. Lets you select the location of data that the plot's using. It'll show you all of your different sources over here. We only have one today, but if you have others, you can select all of your different data sources and their new locations. And this is also useful for you if you move data to an external hard drive or something and you have the same session file and you want to use it later. Restore Session with Sources. So then just click OK. It'll open back everything theoretically. Sometimes it doesn't restore line plots very well. I left all those line plots open, so we have to redo our queries. But the main thing is it left our window the way we left it. It left our keyframe animator. We've got all of our keyframes. Everything, all the work that we did is still there. So that's restoring session and restoring session with sources. Also, we got vectors and streamlines. So we don't have a lot of time for vectors and streamlines, but we have 1 minute. So maybe we skip vectors and streamlines. Is anybody here going to be using vectors and streamlines today? If not, or if you do, you can check out the data and make them. The basic instructions are there on the slide. They're not too hard to do. Or you can watch one of the past workshops. That way we can end on time here. So to wrap up, I just had a couple of closing thoughts, and then I'll stick around and answer questions if anybody has questions. So let's see. So a couple of best practices. So when you're thinking about visualization, so if your data is small or manageable, so we had a question earlier, kind of how do you manage large data? So if it's small or manageable, stay on your laptop or your workstation on your desktop, because you're going to save yourself a lot of headache. Moving to Ibex or Shaheen is going to introduce a lot of complexity, a lot of other issues that come with working on large iron. But if your data starts to become medium or large, interactive visualization on Ibex is great. You can do exactly like we did today. You have the GUI on your laptop. It's connected to Ibex, but all the processing is happening on Ibex, and it's just sending you images over to your laptop. And then if your data starts to become huge, or if you have a really big defined workflow you want to run, you can start doing that on Shaheen. We have recently been able to start doing interactive visualization on Shaheen just like Ibex, but the GPU cluster is another problem. So right now it's only working on CPUs. So if you want to do GPU rendering, you need to stay on Ibex. But the important part is it runs on Shaheen. You can do batch processing there, which is really nice if you want to run on lots of nodes for a long time. And then finally, if you have repeatable or repetitive tasks, make some scripts or do batch visualization. So like all of that color changing that we did on the background today, I would have a script that would automatically do that. So every time I load VisIt, I can run that script. It'll change the colors so I don't have to manually go through the windows every single time I want to change the colors, because I don't like working on the white background and I don't like the black background. So just create a little script, it'll automate it for you. It'll make your life a lot easier. And then I'd be remiss, given that my focus is on HPC, not to mention the HPC resources in a little bit more detail. So you can access them very easily with VisIt. You just have to have an active or valid user account, and then you just load the KAUST profile. So in VisIt, you go to Profiles, and then you just select the KAUST profile over here. It'll install Ibex, it'll install Shaheen, and then from the open window, you can just connect to those directly. And if you want to see the instructions for that, you can view that on the HPC doc website. I can show you that window real quick. So it's under Options, Host Profiles, and Configuration Setup. So you can just install the KAUST profile that way. I already have it installed. If I turn off my VPN, we can think about using this real quick. So how you do that, just open. Instead of going to localhost, say I want to connect to Ibex. So then this will try to connect to Ibex. It'll ask for the password because it doesn't know this computer. And then it'll try to connect. And then it's connected. So we're on Ibex. As you can see, we're on iLogin. So now we can go to any of your spots on Ibex, load data, do visualizations. Very easy. So if you have any questions about that, though, please let me know. Happy to help. But otherwise, thank you very much. I appreciate your attendance today, and I'll stick around and answer questions. So for those of you online, thank you for attending. We're going to sign off now. Thank you. And close.